Hi everyone, this is the gas walkthrough for December 20th. I'm Philip Newman. Today I'm solving You May Be Right by Bill Murphy. This is a consecutive pair Sudoku. We have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, we have some white dots in the grid, and digits connected by the white dots must be consecutive, so have a difference of 1. So for example, 7 is consecutive with 6 or 8. You can go either direction. And those are the rules. And Bill has set this up with the given digits so that we can immediately resolve some of these dots. We have a 6 and a 7 in this row. They're both on white dots. So the 7 can't go next to 6 because the 6 is already in the row. It must be an 8. And the 6 can't go next to 7. It must be a 5. Now, since this 8 is in the box, this must be 6 and this must be 5. Anytime we have a run of dots that all see each other, we're going to have to go in a sequence, either decreasing or increasing. These can be 1 or 3. They're both consecutive with 2. We can't distinguish between them. If this were also in the same box, this couldn't be 1 because then we would need another 2, but since it's in a different box, we can't resolve that just yet. Now this 6 could be 5 or 7, but we've got a 5 now, so this must be 7, this must be 8. Now let's look at these dots. We have a 5 in the box. So these either have to be 1, 2, 3, 4, or 6, 7, 8, 9. But we have 3 of the high digits already in this box, in this row. So these must be low digits. The 2 can't go here. And if you think about what this has to look like, the 1 and the 4 have to be on the ends. And the 2 and the 3 have to be in the middle. So this must be 2, 3, 1, 4, like that. 1, 2, 3, 4. It's the only way we can make that work. The 3 makes that a 1, not a 3, and not a 4 from the 2. And now this is a 9, and this is a 9. All right, these are 1, 2, 3. These are 4, 5, and 9. These are 6, 7, 8. Before we move on to the bottom, I will note here, these are consecutive. They include 1, 2, 3. And as a reminder, anytime we have consecutive digits, a pair of consecutive digits, one of them has to be odd and one of them has to be even. Well, our only even digit here is a 2. So the 2 must be in one of these 2 cells. And that means this is not a 2. Not immediately helpful, but worth keeping in mind. All right, down here we have 7 and 8 in the row together, so we're going to do the same sort of thing. 6 must go here, 9 must go here, and that means this is 9, 8, 7, 6. This could be 6 or 8, and now we have a 6 here, so this is 8, 9. 3 or 5 here. Now here we could go down to 2. We could go back to 4. We can't go to 6 because that's 6. The 6 here means these are going to have to be from 1, 2, 3, 4, 5. And again, we can't have the extreme digits in the middle. This also can't be 5. This can't be 4. These can't be 4. This can't be 3. This is a little bit of an advanced thing, but I'll go ahead and use it. Because if it were 3, we can't go down. 3, 2, 1. I mean, there's no 1 here anyway. 3, 2, 1, 0, that would fail. And we can't go up because that goes too high. That gets to 6. And so now we can see this has to go 1, 2, 3, 4, which it can't, or 2, 3, 4, 5. So this has to be 2, 3, 4, 5. And that 4 results the 2, and these are both 1s. So that was a little trickier to resolve than this up here, just because the digits are different. But they resolve in a similar way, and we end up with our leftover digit in both of those places. These are 3, 4, 5, and again, the even digit's going to have to go on the dot somewhere, so this is not 4. That makes this a 3. This is also not 4, so we get that. Now this can't be 3, so this is 5. This is 4 or 6. And now, because these are in the same box, we have to keep going in the same direction. So if we go 5, 4, this would have to be 3, but it can't be. And in fact, another way to see that, 3 and 5 are both in this column, so this can't be 4. It doesn't have anything to go next to. So this must be 6, and now 7, 5, 6, 7. Makes that an 8. This is 6 and 7 from these down here. This is 4, 1 and 9, 2, 3, 8. Ah! I'm hitting all the wrong keys. 1 and 2 here make this a 3, and that resolves that. The 3 here makes this a 1, and now the only place to go from 1 is 2, 3. This can't be 2, so it must be 4. That's going to place 4 in that row. Here we have 7, 8, 9, which we can't do yet. There we go. This is 7 and 9. Here we also need 5, so it's 8 or 9. And then we're going to need a 6 somewhere here, and somewhere here. So this is 7, 8, or 9, and not 9. Like I've made a mistake somewhere. Oh, 4. Forgot 4 needs to go in this box. There we go. This needs to be 4. Alright, now this is 6, 7, or 8 actually. No 9 there. That's not a 7. Yeah, what I was confused about is that if this were 7, 8, 9, we would have no way of resolving this. That would be a deadly pattern. But I forgot I still needed 4 in the box. Alright, 1 here resolves 9, 1. These aren't 2, 3. These are 1, 2, and 6. This is 5 or 6. This is 1 or 9. I remember running into the same thing when I tested this. It was a little tricky to find the final couple of steps. We need a 9 in this row. So that's got to be the 9. This is 2 or 6. That gives us a pair here. So we're missing 3, 7 here. The 9 resolves 1, 6, 2, 1, 6 there, 8 there. Now we've got it. Here we have 3 and 7. So replace the 3, 8, 2, 8, and a 2 to finish it off. And that's the solution. Lovely puzzle. They'll kind of use similar things at the top and the bottom, but just with a little bit more to think through at the bottom. And then resolving the middle, a little bit tricky, but totally doable. So I can hear my daughter talking very loudly outside. I don't know if that's picking up on the microphone or not. Anyway, I hope you enjoyed that. Let us know how you did in the comments, and I will see you next time.